Okay, welcome back, everybody. This is going to be the last video for 2024. Happy New Year. Uh, in the next year, which starts tomorrow, I look forward to being more consistent, and I do hope that we'll be writing a lot of code in not just in Rust but in any language for that matter, and we'll be exploring a lot of different areas. I do have a few plans for the year, and let's see how it rolls out. So, coming back to Rust hours, in the last video, we built a guessing game. We were following the pros that were suggested in the Rust programming book. In this video, I wanted to take it a little further. I wanted to have a feel of solving a problem that actually I can keep or as a record of motivation in my GitHub. So I wanted to start with solving a problem from John Cricket's coding challenges. So let me share my screen and it. Okay, so you should be able to see my screen now. Okay, so if you search for John Cricket coding challenges, you should end up on Substack's page. If you go to coding challenges, you will see after a certain amount of clicks, you will see there is a list of coding challenges that are available. These are really good exercises to be comfortable with any programming language or a lot of different tools in general. We will be building our very first own WC tool. Now, what's a WC tool? We will go through this document and we'll see what actually it is. So each problem here is broken down into different steps. The first step, step zero, is always about choosing your IDE, your programming language, or having all that set up ready for you. The next step is describing what we want to do as a first step when we are trying to solve this problem. But before that, let's first understand what is WC. So WC is actually is a utility that is available on Unix-based systems, which you can use to count words. It's abbreviation for word count. So let's say we have a file. Let's create a file as test.txt. Let's call it, this is the test. So it's the text file we will be using to test our tool, which is WCRS. WCRS is just using the RS for Rust. And say, let's get started. So it has got 5 lines. You should be able to see some information on the screen. So it says 5 lines right here at the bottom, and it says 86 bytes. So let's print that information. If I do WC and pass this file, it does tell me that there are five lines right here. And if I change, let me change the color. Yep, better. So these are 5 lines and 86 bytes, and this is the file that we had passed to the WC tool. So to get started with the challenge, the first step is to write a simple version of WC. Let's call it ccwc, that takes the command line options -c and outputs the number of bytes in a file. So since we are new to Rust and we are just learning, let's do it the Rust way. We will start off by creating a new project called WCRS. And let me also move the test file in here. Okay. Let's run the code just to make sure that everything is working. So far, so good. Now, let's open it up in Vim. You know, maybe for a change, let's do it in VS Code. Yeah, let's do it in VS Code, maybe. Apologies for the bright light. Let's change it to box hard. And if I set the size be to 23, is it large enough? Yep, should be large enough for you to see. I'm hoping that it's large enough for you to see, and maybe I can also zoom in a bit. All right. So we have our very first, the initial boilerplate code that we use generally get, fn main. For us to start with is what we need to do is very first thing is to that we should be able to accept or pass in the file name to our program. So we should be able to do the way it works in cargo is cargo run is what we use to run our program. And if we pass in hyphen hyphen and the name of the file, it will be passed in as an argument to our application. Nothing happens as of now because there is no code. In our first video, we learned that we can get the arguments that are passed to our application using um, standard env and then args. Now this gives us this args, which is a struct as args type, and this will ultimately give us both the so in generally what happens is in a Unix based system when you run a program it goes in as a list of arguments. The first argument is always the path to the binary that was being executed. So in our case it will be our wcrs program. So the list is something like this. So you will have wcrs being the first one, and then you'll have test.txt, which is the second element in the list. This is at the index 0, this one, and then test.txt is at index 1. So in the first video, we learned that, we can skip it. We can say skip the one, skip 1, which means we'll now have test.txt as the first element in the list. Okay. This returns an implementation of an iterator. Now, I won't be too much worried about impl iterator. It all depends on you could be seeing something of the sort skip args. The type could also be skip args, but it all depends how what the version of Rust analyzer that you have. For me, I don't remember exactly which version it is. Okay, so version 03.2237. If you're using a different version of Rust Analyzer, you could be seeing something absolutely different. But you get the idea. So now this is an iterator. What is an iterator? As far as I know, or in the layman's term, iterator is more like a lazy way of iterating over a collection where each time you'll have to say give me the next item, and once you have that item give me the next item. So you don't load everything in memory at once, rather you fetch as required. It's a lazy loading mechanism. So we can say let file name equals args dot next, and it's complaining. What's the complaint about? The red squiggly line cannot borrow args as mutable as it is not declared as mutable. So we also talked about in past that by default, all the arguments or all the bindings that we create, like args equals to something, it's immutable by default. We have to declare it as mutable. Um, iterators need, when they're iterating through a collection, or they need it to be declared as mutable. That's why it's complaining about, that it should be mutable. So that should give us the name of the file. Let's print it quickly. And right now we are actually using the classic interpolation format. Why is it complaining? Oh, it's okay. As far as I know, if I had something like x, let x equals 10, it should work, yes, but it does not work for file name. And as far as I know, the reason is this is a statement. This is not an expression. At line 6, we have a statement, but when we do file name, this is not uh, this is not an not a statement. It needs to be formulated, needs to be calculated at runtime, because we are doing string dot args dot next. Or is it something else? Oh, okay. Oh, my bad. Okay, my bad. I didn't even realize that this is returning an option. So why do we need an option? Imagine we were invoking it like this. There is no first argument. There is nothing that is present. So that is why args.next returns an option. An option is like, imagine you are iterating over some over a collection, but there is the value is not present there. In such cases, you get a none. There is no value, and if there is a value, you will get a string. So option is an enum which takes the form of this. So you see there the enum has two possibilities. Either the value is not present there. In that case, you will get a none. Otherwise, there is some value, some value. And if the value is present, you will get that value. So this wasn't complaining because option of string does not implement the display, which is required for you to be able to print in here, use it in the print statements. So how do we get an option? We did see an approach last time as well. Imagine it to be a gift you're receiving on Christmas or any time, and you just unwrap, irrespective of whether you if whether it was a prank or you actually got a gift. So in here, if the value will be if the value is present, we will get a string. If not, we will see what happens. And now we should be able to do file name. Yep. Now let's go back and do a cargo run. And we do get the file name. But what if we do not provide anything? It panics. So the thread main panics because we are calling unwrap. And if we were to remove unwrap, nothing will happen. So if we were to say, um, if we were to do this and print it like, I'll talk about what does that colon and question mark means. Just give me a minute. So if we do this and go back here, you'll notice that it will not panic. It just says that the value that we got is none because there was no value provided. And if we were to pass argument, we will get some value. So for any type which does not implement the display trait, which is not, or you can think of it as which does not provide a very convenient way of printing out the information onto the console, um, you get an option to use their debug form. So if you were to uh, just think about it like this, if since we cannot have a proper display message for options, we can use the debug representation to print them onto our console and continue. So we don't need this, don't need this. So we have got our file. Now, how do we open or how do we read that file? So let's start read the file. Now, if I'm new to the language, I'll straight away go to standard.rs and I would search for read. And the first thing that I hit is reads fs. There is a module called fs which gives us the ability to read the file, but it reads the entire content of a file into a byte vector. I don't want to do that. Imagine the file is too big, like you have say 1,000 pages long file, and you or maybe one with millions. So this file will be loaded at once in the memory, which is not a good way of reading it. So I'd prefer to read it, prefer to open it first, um, and maybe then read it. So we can use uh, standard fs file and then open a file. Let's do that. So let f be equal to standard fs, and then we have a file to open, and this requires a path, which is going to be our file name. Okay, and this returns a result, meaning so you can think about results. We have talked about it about results in a very small window, but very generally. So you can imagine any file operation on your system could actually fail, right? It's not always guaranteed that all the operations that you do on a file will always and always be successful. In most of the languages, you will get or in a large number of languages, you will actually get an exception or such behaviors, like something was expected to happen but it did not happen, so you get an exception thrown at you. But in languages like go, you get an error, and same with rust, we get an error, but the only difference is that it returns a wrapped value. In go, you get a sort of you can the function could return a value and a nil, or a value and an error, but in rust you always get either the value or the error, not both. So we can again use, we did use this function last time as well, that it will, we can expect, or we can also run unwrap on it, but expect gives you the ability to print a custom message when the operation fails. So you'd say failed to open the file. Maybe also we should change this to expect and say file name, or just say no arguments provided. All right. So we now have a file at, in f. F holds a file, We want to open it, and we have opened the file. We want to read it now. How do we do that? One uh, thing that comes to my mind, based on the experience that I had, is using a reader, sort of a buffered reader. There must be some buffered reader. Okay, so there is a buff reader. So you open a file, it returns a reference to the internally buffered data. Okay. Um, so you create a buffered reader and then you read through it. Okay. So let there be a reader, which is going to be standard IO and buffer reader dot new. And we are creating a reader for F. So we pass into the inner, we pass in F. Okay. And now what options do we have on the reader? Reader.read, which pulls some bytes from the source into specified buffer. Okay. So we can specify a mutable buffer, and there the specified number of bytes will be read, a chunk basically. I see one more. Read all bytes until a new line is reached and append them to the provided string buffer. So we have a file which has multiple lines and it makes sense to read line by line. So let's do that. It requires a mutable string, which is going to be the buffer. So let's create a string. Let line, it needs to be mutable because right now, if we don't use mutable or mut, this creates an immutable string kept somewhere on the heap, a growable string which is kept on the heap, but it's not mutable because this binding between line and the string, that is line, the variable, sorry, and the string value that is on the heap is not it's not mutable. We cannot use it to change the value on the heap. Now it's mutable, and we need to pass in this to read line. It requires a mutable reference to line. Cannot mutate immutable variable. Yes, I forgot. This also needs to be mutable. This was also mentioned in the document. Here needs to be mutable. So we now have a reader dot read line, and the yellow line says that there is something that we are not handling. Red one means red squiggly lines means there is an error. The yellow ones mean there is a warning that we need to take care of, and we can always run cargo check to get a detailed understanding of. So reading a line can also fail, and that's why it returns a result, which may be an error variant, which should be handled. But if this is intentional, we should always use let underscore, and the compiler will okay. We are not really concerned about the result or errors as of now. For now, what I would like to do is I'm not really concerned about what does it really return. So read line returns a result of use size, and what that result is. Do we really care about that? It returns a zero if we have reached the end of file. I'm not really concerned about the number of bytes that we're reading as of now. So I will go ahead and do an unwrap or expect again. Failed to read line. And right now that error message is gone. At this point, we should be able to read the line, the very first line, and be able to print it. Our build passes, so no errors at least. Cargo run. And yes, we do see this is the text file. So if we are just reading the very first, so what we did is was read a line from the text file that we just opened. So we're only reading the very first file. Now we want to read the whole file, right? So maybe since this is an iterator and we can sort of loop through the iterators, what's the recommended way of doing it? So the read line returns a result. If there is anything that keeps going, there is an okay. The stream has reached the end. Could we not do something like uh, for I'll move the documentation on to my right so that I can keep looking at it in parallel as I type. So we can do something like for len in reader dot lines. So what I'm looking at, just give me a second, let me show you this. There is this function on the reader which says like lines, returns an iterator over the lines of the reader. So we were individually reading each line. Instead of doing that, we can also use read line and have a check of our own. But there is a function lines which returns an iterator, will yield instances of result where we'll have the string of the data, and we can actually use it to iterate over the whole bunch of lines, and it will automatically detect whether there's an end of the file or whatnot. So we don't have to worry about those things manually. For line, what I would like to do is unwrap the line dot spect, and I would say field, and we need to assign it to something. And in case you're wondering how we are able to use this line up here, and then also we have a line at line 17. This is because Rust allows shadowing. This is called shadowing, and you can use the same variable on the next line. You can redeclare the same variable because this is an inner scope. This line is present, but actually in this scope, and then we are shadowing the line using this line redeclaration of the line word and saying that is zero. This is a string type, although this was a result type. And now we should be able to print whatever we are getting. We can get rid of this and this. It need not be, does not need to be mutable anymore. Okay. So this is the Rust compiler working with us so that we write the right program. And if I run the program again, we should see all the lines. Yes. Okay. So we are able to open a file. We are able to read through the file. Now, as the first step in the challenge, we were required to print the size, but it also says you should be able to pass an argument -c sorts. So what I would like to do is move this portion into a function. And I'm not a GitHub Copilot fan or any Copilot or any AI generation code generators as such, so we'll do it manually. Let's call it read from um, f is going to be a string. And what we will do is move this up here. And now we should be able to call read from, this is going to be a file name. So we have an error. Okay, in fact, we have two errors. Let's see what's that. Cannot find value file name. This is true. This is because we have now reweighted it to F and we are good. What else? fs.read. Don't need this. We never imported you, buddy. And in case, okay, so this was that's why I really don't like learning something in code editors in general, because we never really realized when this came in. It was VS Code's magic that it came in. So the thing is, this is a struct, which a buff reader is a struct which implements a trait or a behavior which is about reading in a buffered manner. That behavior needs to be, or the trait needs to be in scope of the program where you're using buffer reader. So that's why you're seeing this present here. If I were to just if I were to comment it out, you see we'll get an error that says no method named lines found for struct buff reader in the current scope. Items from traits can only be used if the trait is in scope. So we are getting this lines uh, from buff read and buff read. And maybe I should have shown you when I searched for it. So I searched for something about lines, or and I came across this buff read, which says there is a function called lines, which sorry, lines, and this returns a lines thing, which is actually a struct lines which implements an iterator. So it implements a buffered iterator for lines, and that's why I was able to use that lines function. Okay, so we'll undo this and our program runs as expected. So we are able to read the file. That's totally fine. Can get rid of this. Okay. As for be able to get the size of the getting the argument to do like so what we want is something of the sort. Okay. Um, which means this this becomes index 0, this becomes index 1, and this is index 2. So before getting the file name, we should be able to get our uh, a line count sort of, or be able to, do we have a name, proper name for this? It's just an option hyphen C. Uh, okay. So this is like a toggle, like hyphen, if there is a hyphen C, if there is not, okay. So maybe it should be a Boolean of sorts. Um, but anyways, we need to first understand, like be able to get the value. So let's call it get bytes, and this is equal to r start next, and we should just use unwrap. Okay, this is a string, but so wait, maybe let me just print it out. Okay, so we do get a hyphen C, which is fine. Now, how do we? Uh, what I'm trying to do is, if this particular hyphen c is provided, only then we calculate the bytes, or we try to fetch the bytes. Otherwise, we don't. That's what I'm trying to see. And so, how do we parse uh, string into a boolean? That is something that we need to figure out. Do we not have get bytes dot parse? Okay, there is a function called parse. What does it do? Parses this string slice into another type. Because parse is so general, it can cause problems with the type interface. Do we have examples? Okay, so we can do something of this sort. So we can declare it to be boolean, and then once we have the unwrapped value, once we have this string, we can call it parse. No, or does it work like this? Okay, so it returns a result. It does work. Okay, now this is actually getting ugly. So instead of doing this, doing it like this, I'd prefer to do it spread like this. Get bytes. I would prefer to use shadowing and do it like get bytes dot parse dot unwrap, and this should give us a boolean. And if get bytes, and now we go ahead and get file size. All right, how do we get the file size? Let's go to documentation again. Returns the value of n file size fields of this metadata. What is metadata? Metadata information about the file. This structure is done from the metadata. Oh, interesting. So all the information about the file itself is stored in a metadata, which we can actually get. Awesome. So this makes it quite easy for us to get. The only problem is that we moved our, we're opening the file here, but we actually need it up here. We need to open the file first. Okay, so we need to move this from this place to up here. Now this becomes file name again. This also poses a problem because now in our read from function we do not have the file available. So we'll fix it in just a minute, but let's get one thing done at a time. Let's get the metadata of the file. We know it's a file, so redundant name. Again, returns a result. Let's do an unwrap. And once we have the metadata, what does it have? Meta dot. If we have a size, returns the total size of this file in bytes. It returns a U64. Okay. So we have the size of the file. So we can simply go ahead and print. Uh, all right. So that is one thing solved. And we should be able to actually run it. Oh, it failed to parse it to a bool because it's a hyphen c. It's not true or something. Okay, super bad. So we got let's get byte is actually equals to it's actually equals to hyphen c, which means we do not want to parse this itself. Rather, what we should instead be doing is uh, if uh, get bytes equals string from now that should work. Totally bad. Yes, 86. And if I do a list in the current directory, we do see that it's actually an 86 byte. So this is correct. Nice. So we have some part of it working now, and we have like uh, obstructed the other path. Okay. So the next thing that we want to do is we cannot certainly pass in the name of the file. We need to change this. And how do we fix it? Could we, how do we pass in the reader to this? Uh, so is there something that we have? Could we, instead of creating the reader up here, could we not, we could do, I think we can also pass in a file, right? So this is a file. What if we change simply this from string to a file? Cannot find type in the scope because this is standard fs and file. Okay, and this becomes f. Okay, that solves our problem for now. Yes, so we are getting the size of the file, and we are also able to print through the file. Although I have a doubt, like this f is not mutable. Like we're not mutating over or not, we're not changing the file itself. Does it need to be parsed like this? Could I not just say, let's do it like this? I get rid of standard fs, and I should say something like use fs file. So, by the way, what I just did is this is known as bringing namespace or not even a namespace, but a type in scope. So, a standard is representing the standard library module. There, inside that module, there is another fs module, which is here. And inside that fs module, there is a type defined called file. This is very much similar to what we have in like namespaces. This is a standard namespace inside which there is another namespace, fs, and then we have file. So not let's not get confused with that. And now that we have this, what I'm trying to say is we don't really need to pass in the ownership of that file. We don't need to file the completely. But what I mean by that, what if I call the read from again with f? It will fail. And the reason it will fail is because we have, let me show you the error message and that will itself describe the problem. The file parameter, this is our function file. It says the file parameter takes ownership of the value. The value moved here, which was the first call to the read from. And then once the move happened, value used here after move. So I think this is something that we should talk about. I'm not really sure if the time will permit it, but for now, I'll keep it as is, and the program should work. Okay, let's go back to the second part. In the step two, it says we should also be able to accept hyphen L parameter, which outputs the number of lines in a file. Okay, so one more parameter, and okay, this is actually not the right way to manage things. So instead of, should we rename it to something else? Uh, Option or flag of sorts. Let's call it. Let's call it option. So we are getting an option, and if this is equals, if that option is equal to -c, we the print size of the file, and if it actually is equal to -l, we will have to then print the number of lines. Which means it needs to change to L, and this needs to be closed. Now there's a problem, and I'm seeing a problem because what we are doing is we need to print the number of lines given the option, but we are actually reading the file here. So instead of printing the line, we just want to increment the line and maybe somehow pass this information back so that we can print the number of lines. And one thing that comes to my mind is be able to, so the syntax to return something from a function is this arrow way of doing it in Rust. What I would like to return is the count of those. So I'd like to return a usize. Now, what usize is? So Rust is a systems programming language. We do not have ints and floats in here. You actually have to specify what is the size of the data you're expecting. So if we are returning, we could return U8, which means an unsigned integer of 8-bit size. You could also return in U16 and U32 and U64. And similar way, we also have I8 and so on and so forth. What USIS does is that it will look under the hood on the architecture. Depending on the architecture, since I'm on a 64-bit, it will do is take about 64 bits, and it will return an unsigned integer of 64-bit. So that's why I'm saying use size. That means it should be able to represent any large amount of file size, and it should be able to count and just return the value of usize. So even if we have a file with a million of lines or maybe even more, we'll be at ease because we're returning a usize, which is a unsigned integer of 64 bits. But if you're running on a system that is 32-bit, it will be U32. So usize returns system specific size. That's all I'm trying to say. Okay. So let's say we have a count which is equal to 0 at the beginning, and at the end you can just return count. But we are not incrementing. So once we have the line, once we are able to read the line, we don't want to print it. So let's ignore that for a bit. All we want to do is just increment count. There is no plus plus, I think. So you have to do plus equal to 1. Again, this is not declared as mutable, so this needs to be mutable. And that's how we can return the number of lines. One thing I would like to highlight here is in Rust, since if the last statement of your happy flow of this path of this particular path is returned, and if a function is returning, then you don't need to do all this return something something. You can simply say just count, and it will the compiler understands that we are returning the count, so it does the magic for you by default. However, if let's say if there was some issue, if there was an error at some point, like there is an expect, what we want to do. Oh, okay. So if you remember, this returns a result. So this returns a line is a result, right? What I want to do is suppose that we were reading through the lines, but there was an error. In that case, irrespective of how many lines we have read so far, it doesn't really matter. All we want to do is tell the program that something bad happened and the line count is malformed. Ideally, we should be returning an error, but for now, let's keep it easy and simple. If there is an error, we want to just return an error. And we can use a match expression here. We did use a match expression last time as well. So a match expression on result is a result is an enum which can have two branches, okay and error. If it is okay, we don't really care about the value because um, we are not using the value as such. We just want to do is count plus equal to 1, and if there is an error of any error as such, we're not also printing the error, or maybe we should print the error. If there is an error, this is what we want to do. We want to print the error. So eprint is very common. It's a macro again. It's print to the standard error. Println prints the standard output. Eprintln prints to the print standard error. So we want to print the error, failed to read the line with error. And I would like to print the error if I can, and just return -1. Okay, so we cannot return -1 because it's a U size, and I would like to change that to I size. I'd like to return a minus value, which is a signed integer. Prefer that because let's assume that -1 represents our faulty read or some sort of error happened, and now that's why we're getting a -1. Because even if the file is empty, the number of lines can never be negative. It always be 0. So you see, we don't need this anymore. So if the line, if there was no error reading the line, we increment the count. If there was an error, we uh, we print the error and we explicitly say that return something. So we are diverging from the happy path, and that's why you need to use the explicitly tell the compiler that we want to return from here. If you were to do count here, it will not work because the compiler is not sure what you're trying to say. You might have meant to return the value. So you need to be explicit in such cases. You have to explicitly tell the compiler, I'm trying to return from here. All right. So far so good. Okay. And now that we are read from returns the number of lines that we have read, I would like to use it in here. So let lines or line count equals this, which is an I size. And now we do is this. If the option that you've received is about printing the the line count, we just go ahead and print ln the number of lines. That should do the magic. Five. So which is expected. If I do a cat on our text file, yes, there are 5 lines and we indeed get 5. But we cannot, does that mean we cannot use -c, which is for getting the bytes, and -l, which is for getting the lines together? As of now, that is the case, I think. So if we do this, the program panics because it says no such file or directory. Reason being, it's considering the first. So when we do a next, okay, let me copy this. Not even need to copy. So if we come here in this output, in this, if you're this executing this, the first call to next, sorry, the first call to next returns -c. So the option will take the value -c. The in this next call, it's not next, we get -l, which is the file name which does not really exist. So we need to come up with a way of being able to pass multiple options to our executable and still be able to generate all that information. All right. So this is, I think that I would like to pause here. Let's take us, stick. It's slow. This is a fun exercise to implement. We have touched upon quite a few things, and we will continue on this in our next video because I don't want it to be stressed like for hours. I think we are already an hour up. So yes, we will. This is where it stays, and we will continue solving this in the next video. If you have any questions for now, or is this if there's something that I should do better, do let me know. And if you feel like these highlights are frustrating, and you would indeed prefer for me to be doing something like this rather, like timing things on our own, do let me know in the comment section. Otherwise, I think I'll switch back to Vim. I enjoy more being in Vim than being in VS Code. It's a lot of information and it's too loud for my taste. Like, it kind of makes it obvious to what you want to do in the next step. Rather, I prefer to struggle with the compiler, fight with the compiler, and learn it that way. So, yep, that's it. That's it for now. Thanks for watching, and I see you in the next one. Thank you.